Hello, welcome everyone to question number 18, delete without head pointer. Let's have a quick look at the question while we're discussing the approach soon. But before that, please don't forget to hit the subscribe button. And if you have any extra email IDs, please do subscribe our channel with those also. And if you have any doubts, don't forget to comment below where you're facing the problem. We will be very quick to respond. And let's continue to the approach. Now, coming to the approach, we have to understanding the meaning before that. So let's know the meaning of the question first. The question is saying that we have to delete a element without using head point. The thing is, we got some linked list. Okay, we don't know what it is. We only know the value. Okay, the question is only giving us a value. Here, node is represented 20. This is the only value we are getting. Okay, and this value is already linked with this linked list. The linked list here we are showing 10, 24, 30. It is already linked, but we are only getting the value 20 and the next address. That's it we are getting. Okay, now we have to delete this 20 and still get the other elements of that linked list. So how can we do that? Deleting this 20 without using head pointer. Okay, we don't have any head, we only have the current element address only. With the current element address, we have to delete this element, and we don't want to disturb the other elements in the linked list. Now let's understand how can we do. Okay, this is the basic understanding of the question. Some node element is given, we have to delete that element and return the remaining linked list without using head pointer. Okay, now let's continue. How can we do that? Okay, now let's take this 10. Now we have drawn 10, 24 and 30. Okay, this is the linked list we have, and this is the value we got. This is the value which was given by the compiler to us as a current node. Now we have to delete this and also reattach this previous address to this one, but we don't know the previous address, the address of 10 we don't know because it wasn't given. So what can we do in this situation is just have to copy the next element. Okay, the next element is 4. Okay, we have to copy this to this one. Okay, let's take another color to represent it. After copying, we get a new linked list that will be 10, 4, again 4 and 30 now. Okay, the benefit of copying the data is we don't have the need of using the head pointer. Okay, now after copying, what will I do is I will just say the dot next element should point towards this value directly. Okay, now if we are pointing directly from 4 to 30, then we are not disturbing the any linked list element in this case. Now after pointing this 4 to 30, what will be the new linked list? 10, 4 and 30. Here we only change the data. We haven't changed the address. So that's why it is working out here. So after skipping the next element, which we already have copied the same data. So there is no difference in that. That's why this method is working. So after copying the data, we just linked to the next element, the second next element of the current value. We are linking it directly. So in this way, we don't have the need of this head address. Okay, we haven't used anywhere the head address here. We have done the work without using the head pointer here. This is the meaning of the question, delete without head pointer. We haven't used any head pointer and we got the output 10, 4 and 30. So this is the final answer. If you still have it understood, let's go to the coding section. Then it will be more clear to you. Now we are inside the coding section part. What we're doing is the same thing. We're copying the next element of that. As you can see, current node value can be anything that the compiler can give. And we are copying the dot next. The next element address we have copied in temporarily in T. Okay. After that, the data. Okay, the current data, we are replacing the current node data with the next element data. We replaced it now. Now we are removing the link of the next element. Okay, now if we use current dot next, okay, current dot next, the next arrow should move towards two elements ahead. So for two elements ahead moving, we have to use 2 times dot next. Now we have moved 2 times dot next. That means we have successfully changed the linked list by removing the duplicate value. So this is the answer. I hope you have liked the answer, and please don't forget to subscribe our channel. If you have any extra email IDs, please do subscribe with those. Thank you for watching till the end. Let's meet in another question.